Back live for a little bit. Light dev session today. Just light dev session. Let's check if I missed anything. User messages. Wait, what? I think, yeah. Does stream work? Oh yeah, we're live. All right, so I think that the goal for right now is just going to be to finish this little demo example. It's probably only going to take me like an hour, if that. We'll push this, we'll hope we don't break anything, and if anybody's around or has questions, then I'll answer stuff there, and if not, I'll just call it and enjoy my Sunday afternoon. Got Baldur's Gate 3 to finish after all. Labs aren't really starting until early January, though this does need to be done. This is a little infra improvement. Just want to make a little demo. Pi less than equals 0. What? So dot get C4. How the heck did that happen? Is there not a bounce check on this? Oh. Yeah, this. No biggie. So what this is just like a super basic test environment. I'm porting the C back to Python as a really just dead simple test. Python environment at 300,000 steps per second is a new one. But you can see actually, look at this. This should be like well over 1 million. Look at all the environment overhead because Python. Rewards. It's also not training. Should be a puffer squared, shouldn't there? Puffer underscore squared. Oh, no comma. There we go. And there we go, 1.1 mil. And trainable. Hey YouTube folks, hey Twitch folks. We're making a little toy demo env in Python, so if you wanted to try out the new ultra-fast puffer stuff, but the C was a little intimidating, this gives you a slightly smoother starting point. Still recommend trying the C, it's nowhere near as hard as you would think. It's actually, we've had brand new programmers pick this stuff up, and it's very rewarding as well. Stuff is just effortlessly fast, but we'll still get stuff faster than 99% of the rest of the field, even in Python here. Huge fan, do you accept resumes for collab? I'm a CS undergrad. Yeah, I've got even better than that. We don't accept resumes, you can just collab. You literally, there are no credentials required at all. You just join the Discord, discord.gg/puffer. You start building cool environments. If you PR a cool environment, I do a live code review. I hang out on stream, I hang out in voice. A lot of the biggest contributors came in with zero RL or AI experience. Like, it's mainly just a matter of like who's actually interested enough and has the time to put in to build stuff. So I built this one, and where's Snake? Snake. This one was by an RL PhD, okay, but then these Go, Rware, Connect 4, Triple Triad, these were by experienced programmer, brand new to AI, relatively newer programmers here, and then this one's brand new programmer, and then we've got a few more in development by new RL people. So it's pretty much just like if you like put in the time and like build some environments, you get code reviews, I give pointers, and then the idea is that like building an environment is the best way to get familiar with Puffer and familiar with the process of like what it takes to get RL to work on a new problem. And then I start onboarding people to the science side. I don't know if you're more interested in engineering or science side, but for people that come over to the science side, we have a lot of big plans for 2025. We're going to be running like huge, massive scale ablations, trillions of steps of experiments, really making RL sane and stable in 2025. And we're definitely looking for people to help with that. That will have a slightly higher bar on it. We just like, you'll need to be experienced enough to not just be totally wasting compute and to be running reasonable experiments. But basically the qualifications there are be a competent programmer, listen to feedback, have some basic understanding of how science is done. Preferred qualifications include never having written Java. I learned in Java. It's just a pain in the ass. Yeah, so either new environment from scratch or TCG is too big of a project to give to somebody new, but like finishing robocode would be a decent project for like a new contributor. I've been wanting to get somebody to do this for a while. It's a really cool tank battle game. It's almost done as well. It just needs a little bit of help. Just joined? Yeah, discord.gg/puffer. So I've been away for the last 2 weeks because NeurIPS followed by being sick. And it's going to be the holidays, and I get to get a root canal for the holidays, so I'm going to be out for a few more days as well. But generally, going forward, a lot more dev is going to be live on stream, so it should be very, very easy to get help. But we're really trying to make RL work in 2025, and we actually have enough devs now, I think, to make it happen. Like, we're getting enough environments submitted. It's really just going to be a matter of leveraging those to run new good experiments and having enough people that are really interested enough to get on board with that type of stuff. I'm still working on figuring out how I'm going to fund like bounties on specific stuff. That's still in the works, but for now, great place to learn. Would you mind taking a quick look at how I generate continuous actions? I think something's up with my code. I copied what you do in default. But when I eval train policies, behavior is really strange. Only ever move or aim in one direction. Sure. Link me code. And I will do a full review whenever you want. Timeline wise, I have a little bit of time tomorrow. I think I have one meeting or like in the afternoon. So I'll be on a little in the morning tomorrow. And then 24th is root canal, so fun. And it's Christmas. I'll probably take like 25th, maybe 26th off. And then I'll have like a few days before New Year's where I'll be like merging more environments. I'm really excited for your environment as well. I think it deserves a better renderer too. Like I think we should make a way better, like a nicer renderer for you. Hold on, my chat's not working. I gotta get the window up with the clickable chat. Can you post the link again? Or actually, I can just type it in. Captain space book. Probably have full review next week. Also, like agents trained before I PR to Puffer. Yeah, that's fine. But like for next week, so let me check Cal. See when I can do this. So a little bit of time in the morning tomorrow. Root canal, Christmas. Maybe if you have time, I can do 26th or 27th. If we just schedule something, we'll do that live for you whenever you're ready. Up to you how many files and layout and stuff. I'm not going to bitch too much if you have multiple files. The one thing I'm going to be petty about is we have to make sure the box 2D compilation doesn't make it hard for users. I mean, I won't have time. Need one next week. I mean, I won't have time this week. Well, yeah, I mean, I'm saying, like, if you do have time next week, I can find some time for a full review. Oh, this week is because it's Sunday. I see what you mean. Yeah, I forgot. In my mind, Sunday is the end of the week. So, yeah, that's fine. So that's, like, right before New Year or whatever. Yeah, we can do that. Oh, right, I was reviewing code. Where is, what should I look at? Policy. Gotcha. What's this? I want to see the scale of your actions. Ops. Ay. I'm not seeing your constants. You'll have to just tell me the scale of obs, but I'll look at your policy. Okay, so you have whatever this is, and you encode num drones. The heck? TH. Oh, torch, that's fine. XY, whether to shoot or not. I think that should be fine. Wait, normal? Is this what I did? I know I have a demo of this. Oops. I know I have a demo of this somewhere. Is it in policy.py or models? So decode mean, decode log standard deviation. And then I do, this is the sample code right here. Okay, so I do take a normal. And then I return the distribution. So that seems fine. Do you know if this network architecture is any good though? Yeah, it's just your parameter. So you're just parameterizing. So you got to just realize this is not the only way that you could do continuous actions. What this is assuming is that your action space should follow a normal distribution, which is actually not necessarily a great assumption. But yeah, it's a little tricky because like continuous is generally less tested and often harder to optimize as far as I'm aware, compared to continuous. So we do want to do continuous, but we might have to test it discrete. Yeah, so this is the point of having you do stuff like this, right? Is you make environments, you try to build policies, and like you pick up stuff about reinforcement learning in the process, right? That was the whole point of the contributor pipeline. Okay, explain to me what the heck you're doing with this network. So you have weapon type embeddings, floating wall type embed, map cell embed. So you have all these different types of embeddings. You've got this map CNN, which is, I don't know what the size is here. If this is like 11 by 11, this is my net that I use for 11 by 11. This is perfectly good. Maybe a little small. I think I use 64 here. I forget. 21 by, okay, so then that makes sense because otherwise it gets too big. Is this a local crop centered on the agent, or is this like a global OBS? Whole map, okay. So I've not tried that before, but that should work fine. Compute CNN shape. Walls. Okay, so the first thing is I would ask why you have a loop here. I mean, this is more just a speed optimization, but there's basically no reason you should ever have a loop here. You can batch embeddings. So weapon type obs plus, yeah, so star. So this is just obs, and then you apply the embedding. Offset colon offset plus. So there's maybe some fancy indexing, but you should be able to do this without a loop unless I don't understand what you're doing here. What's this? Yeah, so same thing here and then same thing here. So you should be able to make this net like massively faster. There's no reason you should have for loops in a forward pass. Bit longer, bit slower though. Then I would be suspicious as how you did it, because it shouldn't be slower. It's like really sketchy to have loops in a forward pass like this. Technically, with big enough batch size and big enough networks, maybe. But how fast is your net right now? Like if you're over 500K, I won't complain. though it is like a little bit, like I can't even read this. This is like, I don't even know exactly what you're doing. I assume it's just 3 different embedding types with some weird offsets, but I can't even tell. But like assuming that you have some reasonable embeddings, okay, then what do? You take 300K on your desktop. We'll get you a puffer box for testing. 500K is benchmark for 4090. And keep in mind, right, one of my favorite things about writing really complicated M's myself is I get to tell everybody else who writes more complicated M's, like writes complicated M's, if your M isn't more complicated than Neural MMO3, then the code shouldn't be more complicated than Neural MMO3, right? And that includes the networks. And that thing literally has an economy in it. Policy can be, yeah. A lot of the time it's like, don't get clever. Like you try something simple and then you slowly build up to something more complex with these things. Yeah, okay, so this is like, if you don't have a ton of different entities, this can kind of work. This is just a flatten as far as I can tell. So usually, let me explain to you entity style networks. And, I'm going to do this for you real quick because you put a lot of work in, so I'm going to give you a nice explanation. And this actually will be good for people watching as well. I'm also create a chat and voice at some point later today if you want, whenever. So here. So there are kind of 2 different ways that you can parameterize a network for the type of game that you have, and it depends on how you represent the observations, right? So one way is you either globally or just centered on your agent. Either way, it's usually more efficient if you center it on your agent. But like you have your agent there, you have your grid. Doesn't matter if the environment is continuous, you can still partition it into a grid. And so you have something like this or whatever. And then in each of these cells, right, each of these cells tells you, maybe it has like a PID to an entity. So this is like entity 1, this is entity 5, this is entity 3. And then you see all these different entities. And then what is the representation of each of these tiles? Well, this is actually going to give you a 3D array, so like 3D. And if we like take this, like this little bit here, and we like zoom in on this, then this is actually just going to be an array that this is going to be like health, and then like, I don't know what else your agents have, like weapon, ammo, all the different things in it. Hey, how's it going, man? Let me finish this explanation and we can chat about your, I'm sure the optimizer thing you want to chat about. So yeah, this is one way to do it. And this is generally what I recommend because it's really easy to write architectures for this. You just take this thing, maybe you have to do like a multi-hot encoding or something. We have examples in the MOBA and in Neural MMO3. But you just do that encoding, you throw it into a conv. Maybe like your own agent has some extra data as well. So maybe like you have more stuff, right? Maybe you have like an extra private data here, right? Maybe you have like inventory, gold, whatever. But then the architecture that you use for this is just going to be like conv. So this is your 2D data, and then you have 1D data, and this goes into like fully connected network, and then these get concatenated, and then LFPM, right? So that's one architecture. This is what I generally recommend because it's easier than the thing that you're going to have to do now with entity style data. the entity style data can be made fast. It can be made very, very good, in fact. And it is amenable to like advanced networks with transformers and stuff. I highly recommend Clement's blog on this, Entity Neural Networks. But the other type, whoops, no. Okay, so the other type here is going to be entity-based, which is you still have your agent here, but now you have your agent over here, your agent over here, and it's not on a grid. And then what you do is you take all these different agents and you take their attributes and you put them into a nice big matrix like this. So this is agent 1, and this is agent 2, and this is agent 3. But you can't just now put these into a neural network as easily because the order needs to be invariant, right? Like, you don't want to have to relearn everything if like agent 1 is here and then agent 2 is here versus agent 2 is here and agent 1 is here. So then what you have to do is some sort of attentional type network. So the simplest possible form of this, which usually doesn't work amazingly, is going to be like you take this block of data and then you like put it into a fully connected net. Mind you, each of these is going to the fully independent the network independently. And then what you do is you like take a max, and then you take a max over this dimension. So you take an entity max, and then you do LSTM. That's one version. This here can be any attentional operator, where any attentional operator takes n vectors and gives you one vector back. So this can actually be like a transformer. I don't know, what's a transformer? Robot thing. I don't know how to draw a robot thing. Transformer. So you can do this. It requires a dramatically different type of network, though, you see, because you get this like entity invariant dimension. And GPU Drive does this. Clemens does this in his work. A few other things do it. It's a little harder, right? It's a little harder. And you can't just slap your old default architecture on it. So hopefully that's a good explanation for you here. Generally, what actionable stuff do I recommend? First example, yeah. First example is usually the default. Now, if you don't want to go through all that work just yet, what I would recommend to you that would be a very quick exercise is to add a flag, and this is actually really good for our research as well. We would like to have this if you're amenable to it. Just add a flag to your environment that is like discretize equals false, and you set discretize equals true, you turn the action space into multi-discrete instead of continuous. How would that work? Well, let's say that your action space is like -1 to 1, right? Then what you do is you do discrete of 5, and then you just map like 0 goes to -1, 1 goes to -0.5, 2 goes to 0. You see? So it's very easy to discretize and turn a continuous space into a multi-discrete space. And because you're doing low-dimensional continuous control, not like really fine-grained continuous control, this will work perfectly fine. And this is done widely across all different branches of reinforcement learning. So that would be my recommendation if you are concerned about the continuous actions and you just want to test your net. I would suggest you do that. And in fact, this would be very helpful to us with PufferLib. Because one of the things that we want to do over the next couple of weeks or months, Pablo released this thing, which is a continuous version of Atari. We want to add continuous actions to some of our environments, especially Atari, but also maybe some of our more complex EMs. And then we want to really understand whether continuous action spaces are fundamentally harder to learn, or if there's some algorithmic deficiency that we can fix, or something similar there. So this is one of the branches of research that I think we want to do, and this is in fact something that I've told Spencer about as well as maybe one of the things he can look at. But he is looking at it in the context of like Pullman breakout. Any other questions? posted a video on YouTube. Where's the video? Oh, is that? Yeah. The policy that just like shoots in one direction. I'm not an oracle, right? That's just a crappy policy. If you link me want-to-be curves, maybe I can tell you something. I'll look at your want-to-be curves for you. Oh my God, are you still here for PSGD? We can look at that after, if that's what you're here for. If you're, unless you're just dropping in to say hi. Yeah, so this is, do you have episode return on here? Okay, this starts way too high. Yeah, this policy loss is nuts. Just lurking? Yeah, no worries. We can start the like algorithmic collabs whenever, pretty much. It's just gonna be like integrate plus sweeps. We can probably get you a box for that. I think we might have some spare at the moment, we'll see. But yeah, comprehensive ablations is what we're gonna want to do. Train reward at top left. Yeah, I saw it. Wait, so slow. I literally have Python M's that run that fast. Very simple ones, but losses. What was I looking for? Oh yeah, these are kind of silly. Integrate with heavy balls since many option methods. Yeah, try it. I will help with that for sure. Okay, so I gotta ask you, is this 16 total environments, or does each environment internally have a bunch? Is it 1536 internal M's, is that correct? A batch. Per puff round. Okay, so then what's gonna happen there? That's kind of sketchy. I teach you how to do some math. It's very simple math. Okay, so 1536 times 16 environments, right? All right, that's what you have, and then your batch size is 262,144 divided by this. That is the effective horizon over which you're able to compute returns per environment. So basically, you're getting, in this optimizer, you're getting trajectory segments of length around 10. Not good enough. You've got too many environments. I would generally suggest 4096 or maybe 8192. You got 3 to 6 times too many environments at the moment. There may be some other stuff screwy, but the policy loss is nuts straight from the get-go. Your policy loss should not look like that. And you can see basically that this is not learning anything. This is flat. This is complete policy failure right here at the top, complete collapse. That's what I would suggest tweaking first. Like, what do I do for NeuroLemma 03? So for NeuroLemma 03, I've got 260K with mini batch of 32K, and I have a total of, this is internally, each of these has 4 environments with 512 agents. I think this is 8192 total agents. And that's like cutting it close on the horizon lengths. So those are my recommendations to start with. I'd also just try a massively simpler network architecture, you know? It's kind of crazy to write a network like the one that you have before you have some baseline training. Those are my recommendations. Cool. Well, if that settles stuff, I'll keep finishing this little toy end. We now have Python stuff training at 300K steps a second. Pi puffer squared. It's puffer pi squared. Where's this command? There we go. By lowering m, batch size is large. It doesn't have to go higher, though. It's like, I'm not telling you that it has to go higher. I'm telling you, you probably have too many environments. Like, okay, the reason that we do the batch sizes that we have, and like, you want to have a forward pass batch size that saturates your GPU, which means that you need to have enough environments to make a batch size big enough. For small networks, that's usually around 4096, sometimes as low as 1024. And then if you want to squeeze the last little bit of performance out of it, you use at least an asynchronicity factor of 2, meaning that you have a bank of environments that's running in the background while the bank of environments that you're currently using is stepping. So then like 4096 environments times 2, 8192 total agents. So if they're multi-agent environments, however many you need to get 8192 agents, with 4096 agents used per forward pass. And then you want to make sure that you're at least getting a reasonable horizon, 32, 64, ideally 128 times the total number of agents is going to be equal to your batch size, divide by something between 4 and 16 usually, and that gives you your mini batch size done. Oh, I think I know what they broke here. Ah, this is probably not as fast as it could be. Still no? I don't see a 1 on here. There's the 1. Where's the 2? Oh, I haven't added it yet. There? Yeah. Target R. Ah, so this is the wrong one right here. This is R. Solved in about 6 million steps. Mind you, we have crazy large packages. So this is, even though a very simple task, it's not designed to be sample efficient. We only care about wall clock in this particular case. Now let's try the C version. Hey, welcome. How's it going? And for whatever reason, the Python version learns. in fewer steps. Is this broken? Unbreak this somehow? I think it should learn by then. Maybe the environments aren't, well, they would have to not be identical, right? Train num_ems, m batch size. Yes, this is correct for, like, they actually should match here. It's very odd. Yeah, so this is like solved. Let's figure out why this does not work the same. Oh, and then also we gotta try. Okay, you can see that this is different. What if I do vec native? Should be the same. Yeah, it's the same. So it's not the vec, it's just something with this specific env, maybe? It's kind of weird. So hubs. Try to match this as closely as I can. Take a 0. Get a random position. Not equal. This should be or, not and. That might change the learn dynamics. No, it's still pretty much solved by 6 mil. Okay. And then step. We set the actions. Terminals goes to false. Rewards goes to 0. Hubs goes to empty. This. Down +1, right, +1, up, -1, left, -1. Tick is greater than 3 times size. Or that, or that, or that, yep. Let's get this to true. Reward to -1. Reset. And then we set infos in this case. -1. Return. Evasions, rewards, terminals, truncations, infos. Very good. And then what else here? So n, r size, c size, which is very good. Right? Yep, that's what we want. If this is this wrong? Let me see. No, this is correct. Observations of positive target. Then we set terminal to true, reward to 1, we reset. Okay, and then we do this. And all this. And this is basically now line by line equal. So why does one of these learn perfectly and the other doesn't? I think. Do I do anything with the RNG? This could be an RNG thing, right? Make sure puffer's still good. Okay. So we can see pi squared is harder to learn. Something changed because we used to not get a ton of these warnings. So some compile settings need to be fixed here. Fine for now though. I think these are just like all weird pedantic warnings. Well, isn't that interesting? Now it doesn't learn at all. So very well can be something with RNG. Well, is this going to give you, yeah, this is going to give you the same on every reset, I think. So that's bad. What if we do it on allocate? Okay, still no. I would think this would give you unique seeds. I don't actually know for sure that it is seeding, to be fair. I can't see why it would be, actually. Because we're not spawning new Python processes or new C processes. It's all in one C process. Okay, what else could this be? Like, why would this then be hard to learn for some weird reason? This is like line for line the same. Discrete of 5. Oh, this is the same. With U and 8, right? I. Yeah, this is fine. Reset all the M's. Kind of bizarre. Pretty darn sure these match exactly. I'm trying to think what would be different here. So mem set to 0. Empty is 0, right? And then agent. Size over 2, yep. Ticket set to 0. Makes random. Observations. Actions of 0. Terminals. That's fine. You do this because it's like this looks line by line identical to me. But they're not training the same. Am I like messing up the number of environments somehow secretly? Nope. Oh, does it not train as well as it used to now? Hold on. I didn't change anything that should have made a difference. Oh no, it's just RNG. Yeah, just RNG. Yeah, no, there it goes, just RNG. Sure. Yeah, this is fine. Let's implement the renderer. So we'll train this policy. Actually, let's make it train for less time. It's not annoying. Yeah. So we'll train this policy. And then we're gonna look at it, see if it looks weird. Okay. Grid equals self dot observations dot reshape. Not getting any render mode. And C. Okay. So this is reasonable, but if you'll notice, it's only in one direction here. So I didn't fix. I messed this up basically. So probably it's harder when you do it this way. Yeah, that's more in line with the other environment now. This is why you always freaking render. You will always be wrong until you render. Always. Even on the most basic of things. "101 lines. 100 lines. Cleaner. If I go back to 20 mil, see if this matches the C version now. Roughly matches, doesn't have to be exact. $400K. So there goes the camera. Fix this. Okay, there's the 20 mil, stuck at 0.8. I wonder if we broke something though, because I thought that it would work before. It's a very easy environment. Try this one. Target C. Okay. It's about the same, 85.85. And let's see if it's any faster. I think the main. It is actually. And there you can see it matches. So there's a little RNG as to how well it does there. Probably bad hypers. I'm gonna add this to the commit, and then I'm gonna go check to make sure that it doesn't work in the older version. Upper squared. I also think I should just make a new file real quick. One 496. And batch size 4096. Like this. Yeah, this way it gets its own. So we need to figure it out. There's like some weird thing there. This works, but there's something weird. Good. $370K. What if I do 4 workers? Does that change anything? Maybe. It's actually slower still. Suppose makes sense. The emp is just fast enough. Like this. Yeah, the multi-processing overhead is there even with 1. That would get amortized with pacing. So why does native not work here? Oh, because you have multiple. Yeah, it's because you have multiple. That's fine. I just need to add a warning is all. Vector. There we go. We can probably handle this more transparently, but I think this is good for now. This just required a lot of little silly changes for this this API improvement. I think it should be a little faster though for other stuff like 100,000, however many 100,000. Python's pretty good. The only other thing I want to do is see if I can get it even faster for today. Status. Forgot butterfly. Okay, that's everything. Try this first. Okay. We're getting somewhere now. I think you need to have a ton of M's, is the only annoying thing. Oh, this needs to stay at 192. You want more workers than this. Like, I think this is going to be slower. Oh, nope, that's fast. There we go. Where's the overhead coming from? $62, $58, $43, $42, $16, $11. Lower miss, maybe? Slightly lower miss? That doesn't seem very significant, right? 16, 15. It's a little significant. 0 seconds, 0 seconds. I mean, I guess just too much info's reporting. Yeah, it's literally just info's reporting, I would imagine. Slightly annoying. Not much way around that. I guess I could change the reporting interval. I would like to get 1,000,000 and see. I can't do it with the same 4096 environments is the thing, right? Yeah, I have to add asynchronicity. I could do it with 16K environments. 16. Still no? Yeah, then it's gotta be the, worked. Works. 28. No, like this. Size. I refactor a little bit. Just a little bit, I gotta refactor. Just take this down here somehow. Else. Do it like this. There. This is how it is. Try this. Port size. There we go. Oh, it was 900K. What happened? Bet those memes are getting to it. How's this? Well, now you can't tell. Try this. It's just really hard to get stuff to run that fast in Python. Holy. I honestly don't think this whole report thing is even good because it makes the example more complicated. I don't think it's worth making this faster at the price of, but I will keep this logic because I think this refactor is decent for the Python version. So what I'm going to do is undo all this stuff. Paste this here. And do this. I think this is good. So you can actually see there, it's not even the infos. We're not even returning the infos. So it's just multiprocessing being annoying. Okay, so now this works. Maybe I can find a config for it. Maybe 8's better. $940 stable. No, not stable. 900 stable. About 4. Much slower. Oh, actually, we see 9% end time there. I missed that. If I do 16, do I have 9% end time? No, but we get more synchronization, maybe. and this is actually slower. So let's do 96 times 3, 1228. And workers. Divide by num workers. Workers. There we go. It's 1,000,000. Yep, 1, 4. And just pi squared. Or no, wait, is it puffer squared? There we go. One other thing I want to do. Can I do like trying to do some policy? My desktop just goes nuts whenever you use the multiprocessing. You see the CPU ports. Just trying a couple things. Fiddling with it for a little bit. There we go, that's better. It's a little bit. Yeah, it didn't help. Just trying to get something reasonable. That might have been a little much. I would have expected that to have helped. RL's weird. We'll tune it at some point. It's an easy end. No point doing it this way. This is the type of thing you totally just automate. Basically, very, very simple end. Bad hyperparameters makes it look like it's really hard to learn, but it's not. It's just bad hypers. We'll leave it at 017 or whatever the original was. I'm going to train this. I'm going to post a little quick clip. I'm going to call it a day. Goes. I love how Ubuntu has this little recorder built directly into it. 2024. Okay, and I just have to convert this. What the heck happened here? Why is it like, why did it record this top portion? And mod. There we go. It feels good to post that, given that this stupid-ass library now has 17,000 stars, because they claim to do that and lie about it. It's fun to just post that a couple days later that we actually can do that, at least for simple environments. Let me commit all this stuff up. Serial support for native PufferLibs up to 1 mils. Yes, training here on items. Required manipulation refactors. So we'll wait a bit. We'll just YOLO merge it. Hey, just got here. What is it with Genesis? It's fake, is what it is. They just massively lied about it, is all. Yeah. The person to follow for this, my go-to in robotics, is Stone. Can't sign in, but yeah. So basically, they're a bunch of lying shills, and another day in AI. Stupid. I suggest you check out Kyung's. Well, Kyung has some cool stuff too, but if you're doing heavy robotics, then check out Stone stuff with Many-Scale. If you have non-robotics, like non-super heavy physics stuff, check out PufferLib. I don't know if you're doing heavy physics or not. If you're doing like light physics or just like non-physics based sim, you check out PufferLib. We actually have million step per second training, and on much more interesting environments than this. I'm gonna just YOLO merge this thing because I'm sick of having dev branches that take forever to merge. I won't ship the pip package though. I'll leave the pip package stable. Yes. I just gotta send this to somebody on Discord. This was a request. Very good. It is 4:43. I think if there's anything else I want to do right now. Anybody need some help getting started with Puffer or anything? I'm trying to think if there's anything else I want to dev on right now, or if I'm just gonna, call it and enjoy an hour off or whatever Sunday before dinner. There will be tomorrow. There will be more live stuff. Possibly more code reviews or dev or whatever. I'm going to be live streaming a lot of the dev now. All this stuff is free and open source. If you want to help us out a ton for free, all you gotta do is start the repo. Really, really helps us. Come on, don't let the fake repo have 10 times more stars than Puffer. We were the fastest growing RL library, I'm pretty sure, of the year, until these guys just decided to come out of left field and lie a bunch. Would you consider doing a tutorial video for how to use and create stuff for Puffer? There's lots of there's like lots and lots of tutorial material out there, man. Here. So we've got this blog that gives you high-level overview of all of our latest stuff. We've got this RL quick start guide for newcomers to RL. We've got this single doc page that's just like a tutorial walkthrough of everything in Puffer and how to use everything. And then for 1.0, I have a video showing going through stuff, but this covers it pretty darn well. It's really, really simple. If you want to work on getting CodeBall to train. Oh, are you on stream? That'd be sweet. Oh, okay, so yeah, you're listening. So yeah, awesome. I will do that. Yeah, link that. I'm gonna use the restroom. I'll be back in a minute, and then I will be more than happy to get that set up. That environment looks awesome. This will be a real treat. Be right back. Okay. This repo is private, my friend. Check out branch. Do you not want to just PR it? Neverick/PufferLib. Oh, I see. Let me see. Where is it in here? It's not in Ocean. This is where we would put it. Branch code ball, gotcha. Okay, let's see how you did this. So we got statically. Oh yeah, you made your life a little harder than it needs to be here. You can just add this to our main setup.py. Local dev. Well, typically what I suggest contributors do is just add it like the way that we would add it as our real env. It'll be just as fast for local dev. Build Ocean, but that requires... Yeah, but the build Ocean, it's in the root directory, which is where you run training from. Okay, sure. But are you building through Python every time for dev? Like, the Python compilation's really slow. I generally suggest the C builds for development. I never use like Python build while I'm building new M's. I only do that when I'm integrating. It's like dramatically faster to just be running the C back and forth loop, and you get better compiler messages as well. Yeah, it's pretty slow, yeah. So I will show you how I would have suggested setting this stuff up. What is your preference on how to do this? So I can copy stuff over and just like manually make the PR. If you want to be listed on the as a contributor on the repo, it's probably better if you PR it yourself. Would you like to just PR like a codeball branch off of 2.0 dev if you want to do that? And then I can help you PR and like merge it? Or are you just looking for me to like play around with it and see? Like, what do you want me to do right now with it? Currently just play around? Okay, I can do that. Gotcha. In that case, I'm just going to clone this separately. And you just go into Puffer, Ocean, Codeball, oops. Check out. Pip install. This. Nope. How do you install it? Build ext? Or do you need raylib? Do you just stick raylib into here? Oh, I probably don't have Raylib in the root. Hold on. Oh, geez, you're on collab? My guy, we gotta get you a better dev setup. Holy hell. You're on like ultra masochism mode. Collab was for testing. Okay, fair. I generally just do Docker for that, frankly. It's like the Docker's so easy, provided you have a GPU. We don't ship CPU containers at the moment. I don't know. Docker's just nice. Doesn't really make sense for CPU though, to be fair. It's mostly like all the CUDA bullshit. It still gives you consistent dev environment though. All right, and then how do I run this? Codeball.py. This is a perf test, maybe? Make run. You have, those are Mac OS arguments right there. Let me see. I hate make files. Can I just do this? What happens if I just do this? Implicit. How does this work if you don't have time? Oh. Okay. LGL. LOBC. I don't think you need either of these though. I think these are just Mac thingies. Cannot find. Yeah. Oh, you still watching this, Captain, as well? Do you need OBC? Hold on. Ah. So this is not linking Raylib now. You're missing lraylib. Fuck. Flags. These flags. Where are they? Right here. Build from root. That'd be better. Whoa. Does this have a train policy already? What is this? How is this? There's no way this is random actions. They're following the ball. Right? Ay, 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 ay. Freeze. Is it a scripted policy? Scripted, okay. I was gonna say, that was like, I'd be very impressed if you'd already done that. I'll like, yeah, okay, vec3 subtract. What's this? I guess this is your function. You have weights loaded in here. Wait, do you have a network? But they were bad. Okay. Well, we can help with that. I mean, this is freaking awesome. They don't use linear LSTM, so they don't run in C. I mean, we have several examples of dedicated C networks. They're not that bad to write. I did the neural MMO 3 one in C as well, so it's not that hard. This is really cool to watch. This is good physics. Is this just your own physics, or is this box 2D for physics? LLM translated. I'm kind of surprised that even works at all. Basically open sourced a handwritten physics sim. Oh, okay. That's cool. No, I prefer self-contained. Self-contained stuff is good. You got some freeze to write, I think, here. What would you like me to do? What would you like me to do with this? Do you want me to read through code? Don't see leaks on my machine. That's because on Mac you don't have fsanitize. Fsanitize doesn't work correctly on Mac, so you're not actually getting the sanitizer information. Train and look at the rewards. All right. Puffer code ball should be. It outputs, yeah, it doesn't work nicely. This is just a bad PR that I merged. I've already fixed this, I'm pretty sure. You just happened to get the branch at like the hour interval in which I pushed that. Let me go get my key. It's that fast on CPU. What? What is? This? This is running GPU. 100K. Hang on, let me figure out where I put Discord so I can still read your messages. Change the... I didn't change anything. There might be an auto detect. Okay, so we have... Well, this looks good. Return goes up, right? I didn't change the config at all. Let me see. Wait, what the heck do these semicolons do? Is this a comment? I thought it was a pound. I didn't know that was a valid comment symbol. Device. $100K on CPU would not be surprising though. We do get 100K plus. We can actually get like 250K for some faster M's on CPU. Puffer very fast. 200K GPU is kind of embarrassing though. We have really good machines. You will get access to some for running experiments on this as well. This is a large enough contribution to merit that. So you can look forward to that. Slow. Let's see. Let's start with your policy. MLP policy. Where is the, whoops. MLP policy. Okay, so you just did a fancy thing. Is this policy copied from somewhere? Do you know that you actually need these extra layers? It works slightly better than linear LSTM. Well, it's just an extra layer. Right? I'm gonna try this policy real quick. It should work. So num robots, num nitros. This is 6 agents per environment. Is the are you controlling all of them? All are controlled by the network. Okay, so it's a slightly awkward number. Let me think how many M's that should be. Uh, 682. It's annoying it's not divisible, but I think it's fine to just round down. 682. You can raise it to, oh, that's even better. Let's do 8. That's nicer. And then we divide by 8, so it's 512Ms. Is it possible to make the parameters for the model I don't know if I just did it for R and N or for model or whatever. Okay. Could a device side, huh? Is this policy? Oh, it should be fine. Is there something weird here? Try this. Nope. Pound works just as well. I didn't even know that I didn't even know semicolon was a thing. Nah, 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 nah. Batman. There's your issue. So that's not going to go anywhere. Why nans? I assume that that means your observations are actually nan. Does this thing actually handle number of robots correctly? For simulation, yes, it is possible. I see some nans. Why is it 4096 by 10 by 9? That seems weird. Number of robots plus 2. 9. Should be typed, TBH. Python type checks for you. Python type checks for you. It's not going to type check individual elements. It'll check when you like pass the tensors in. What does that do? Python doesn't actually check the types. Like, you mean annotated? NumPy struct? Oh no, yeah, you can do that, but we typically don't do that for native environments because it adds overhead. This is totally fine. It's just there nans in here somehow. So I see the third one and the sixth one are nans. Does that ring a bell? Why is there so much stuff in here? Is there like substantial logic in Python? Z position of the first robot. I'm not sure how you have this thing working here. Oh, you have this make, I see, you have this make observation buffer thing, okay. Hi Noah, wanted to finally get to work on TCG, awesome. Do you know what the next step that need to be done there? Yeah, so if you want to just do something simple to start off, I would get a land area working on the side, so like the lands are displayed separately. And then the bigger thing is, I think right now you can attack and block with the same card on the same turn. So fix that so it actually matches magic, and then after that, you can start on some like basic spells. Probably start with like instants and stuff, and then work your way up to more complex stuff from there. There's already a stack implemented and everything. And I will be around for pretty much all the winter break as well to help. Actions on Python side and C side are different. I don't know if you're also on the Discord now, Noah. I have the Discord open. Well, you see it up there. Helping this guy as well. He's got a cool end. Very cool end. Translates from 8 discrete actions to 2 continuous variables. Is there anywhere where like num robots would be hard coded to 6 or something? Because when you set it to 8, stuff breaks. Let me just double check that for sure. What if I set this to 32? Yep, still broken. I'll set it to 6 for now. We'll just have to figure out 6 times 128 maybe, times 256. 1536, that's too small. 3072 maybe. So this is going to be 3072. So this is what, 6144. And then batch size will be like times 16. $98,304. Yeah, so that actually works. Breaking my shell. Slightly better. $400,000. So according to this, your environment is slow. Possibly you're losing perf in Python or something. I don't know why you have the amount of logic in Python that you do. I think that you should either, option one would be to make sure you're not calling back to Python or to C, calling back to Python in Python. The easier thing is to just like follow the way that we do our Python binds and move most of it into C. It's pretty easy. I actually find debugging C way easier than debugging through Python, because in C you just boot up GDB, right? Whereas Python, it like converts it into a big giant mess of C and it's kind of a pain. So it's actually, I think, easier to have more stuff in C rather than less. But I got you to 420,000. Not bad for a few minutes work. You can see 56% env time right here. This is how I know that your env is this low, you know, the bottleneck. With observations as small as you have, this is like an easy million step per second environment for training. Easy million step per second train. And in fact, it's a pretty nice opportunity to experiment with some cool architectures, because you literally just have entity data. So I can show you some cool stuff with that. I don't know if you were around for the earlier spiel on that, but I started this stream, like close to the start of this stream, I gave a pretty detailed overview of like different types of neural nets for different types of data. Moving observation to C sped it up quite a bit. Fix actions to be discrete and pass other buffers to C. Well, I wouldn't just make everything discrete, actually. What I would do, and because this would be really helpful for research as well, I think we have an example of this in MOBA. You just add a discretized flag to, to the Python setting, right? Or a continuous flag, whatever. And you can set the observation space to be discrete or continuous. So you basically can support both. There really should not be any overhead from one or the other. You move the conversion into C, but you make it optional. It's a pretty cool thing, because then you can train with discrete or continuous action heads. You can discretize for now, but I would definitely keep it in mind, because like, it's pretty cool to have the support for continuous actions, and it'll be really helpful for the research as well. Currently in Python, yeah. Just look at all of our other environments. Like our Python binds are really, really small. Yeah, you can totally do that. I think we might even have that in MOBA. I don't know if I kept that code path working, but the idea is there. Well, you just like add a discretized flag and set the space conditionally. You use a float for float array for observations for the, or not for observation, for actions, use a float array. And then, if it's discrete, well, it's an int, but it's in a float array, it's just fine. And if it's continuous, then it's just continuous. So this thing is at 17.3. Yeah, so it learns up to here and then it stops learning. Is that what happens? Does it run to the center? I don't know, I haven't. How do I run it? I'm not sure if it saved a policy. So here's the other thing, Nev, that is probably tripping you up. You have a self-play environment. So as soon as you learn something, your opponent has learned it as well. We do support self-play, but for early environments that are like new in development, what I would suggest that you do is you add an option to make one side scripted, and just use your current policy that like pushes the ball for scripted, and then get win rate versus the scripted policy. And then you should be able to train, your policy to consistently beat the simple scripted policy, and then you can go self-play from there to get like superhuman policies. But that'll be really useful for debugging. I literally just gave Captain like the same advice earlier today. He's also got like physicsy environment. Python, football. This one? Hmm. I don't know, it might be slightly better than random. It's hard to say. I haven't seen them own goal it from the start yet. Tried to hit it out of the way, it looks like. Yeah. It's probably pretty bad, but better than random. Current reward is just running to the... Oh, I see. Well, then, yeah, it's not doing that, obviously, right? I would check rewards because often, like, you're forgetting to reset them or something at the start of a new step. Like, forgetting to reset your reward is very common. Make sure your buffers are actually making it into Python, stuff like that. Is it the only environment in experiments? How do I know? Yeah. No worries. Let me see if there's anything else obvious. And then I gotta run to dinner. This is an awesome end, though. I think do your discretization or whatever, port some stuff to C, add scripted policy option to the environment for the opponents. Yeah, I'm looking at your other stuff first to make sure you've got reasonable configs. Batch gamma, J lambda, yep. This value function coefficient is low. There's no reason to have it this low. Leave it at 0.5. It's just going to create jank. Don't mess with the clip params and the VF coefficient if you don't have a reason for it. Reward code. Goal scored. Well, you do actually have more than a. Let me see. Is this it right here? Is this all meant to be inside the loop? What's this? Well, this is logging, that's fine. Goal scored reward looks fine. To get used. Yeah, you do have a goal reward, don't you? I think I gotta go. I think dinner is currently ignored, didn't do. Okay. So one thing I will tell you, continuous rewards can be a little tricky because the delta between like moving a little bit to the center or a little bit away is very small. So what I would do is I would replace it with like a constant 0.1 if you move closer to the center, and negative 0.1 if you move farther from the center. I would try that if you're just trying to get like debug it. Continuous rewards are very tricky. Dense rewards are good. Continuous rewards are a little tricky. So I've given you, try those rewards, scripted opponents, proportional to distance change to center. Yes, that is fine. Roughly scale of like 0.1 for really dense rewards like that, 0.1 to 1, somewhere in there. That's what I would do. Proportional to change, not proportional to absolute distance to center. Yeah, so that would be my suggestion. Other than that, if this is most of the code, if it's like 1,000-ish lines, we can definitely clean some stuff up and get a nice clean merge of this pretty soon. Yeah, you just see you have, oh, I guess you have a separate renderer, huh? Only 200 lines though. I just put this all in a file. I'd get rid of some of the macros on like the if defs and whatever, but I'll help you with that stuff. All right. I gotta run to dinner. Awesome environment. Fix some of the stuff that I suggested, and then I will be around tomorrow or whenever. And yeah, hopefully we can get something cool training. I think this would be an end people would really be interested in. For other folks watching, I stream this stuff a lot. All this code is free and open source. If you just check, not this one, puffer.ai, GitHub, star repo, helps a ton. Also, you can join the Discord, discord.gg/puffer, or click right here, and you can follow me on X. I post tons of RL, and you can see when I'm live as well. Thanks all, and